So I really wish that I could just surrender my time to hear more of Kavya because that was a really awesome talk. I was enjoying that standing backstage watching it. Okay, right. So I'm Tyler. Again, CTO of Fastly. You probably heard of Fastly by this point, but if not, hi. We're like an edge cloud, which means that we offer services like CDN, image optimization, WAF, and so on and so on. So, right. What I wanted to do today is actually take a quick step back in time. In fact, it's back to the old year of 2013, right? In fact, it was at Velocity 2013. Moreover, it was at Velocity Europe 2013 in this very hotel. In fact, the story takes place in my room at this very hotel, while this handsome man was speaking here on this very same stage. So Fastly was small enough at this point, we're closing in on 400 people now. This was still at the point where we were 25 to 30 people. So we're small enough that we were still all sharing rooms and so on. So I was sharing my room with one of our first engineers, a guy named Ian, who was really into wearing his Hello Kitty pajamas. This is totally irrelevant to the story. I just really want to set the context for you as I go into this. So what I would like to talk to you about is what I like to refer to as the Great Velocity EU incident of 2013. Okay, so we had this relatively new project. It's an internal project, and it was something that runs on our switches. It was the beginning of our our in-house SDN that we built. And it turned out that this particular project had a bug. The bug was that after a certain series of server failures, it would start routing a certain percentage of traffic to a dead server. Okay, that's really bad. Crap, okay. So when that happened, though, it caused a certain percentage of the requests to fail, of course. Even back then, of course, though, we still had multiple levels of redundancy, and we had failure checking. So we had another layer above that that would detect the fault happening in a single data center. And so what it would do is go, okay, well, this one appears to be having some issues, so let's pull off the traffic from that one, let's send it somewhere else. Okay, that's great. So what it did is, it did that. And then it pushed the traffic onto a different data center, which ran into the same bug. All right, that's even worse. Okay, so this happened a few more times, and then we hit another problem. That failure detector was sending so many up and down requests for DNS that we actually crashed our DNS provider's API. This is it really just everything goes bad from here. And then finally, to cap off the whole damn thing, these systems were being taken into and out of production so frequently that it ended up causing a flood of traffic to hit our control plane, which then also crashed. So that's actually me. That's me at the end of Velocity EU 2013. It's a selfie. So all things considered, this wasn't actually that bad, right? At the end of the day, not that many requests actually failed. It was a very small percentage for a very short period of time. But here's the thing. The problem is that none of those things that I just described were obvious when they first happened. I ended up spending the entirety of Velocity EU 2013 up in my room trying to debug what exactly had happened, because all we could see is a series of metrics and then everything nosediving briefly, right? And the problem is this is an example of trying to debug problems in a widely distributed, relatively coordination-free type of distributed system. And it turns out that debugging these things is really hard. Reasoning through the correctness of the system is very hard. And then even if you write it almost correctly, debugging it when it goes wrong is even worse. It's basically this, right? It's the same fallacies of distributed computing that we've been talking about since the 1980s, however, just taken to a much greater extreme, which really puts things like this into a different type of perspective, right? So this is clearly something that we should be absolutely driving toward. However, when I read something like this, I'm like, oh my God, I really, really hope that they are using, say, formal methods and so on to do this, right? But okay, so it's not all bad news. Since 2013, a lot of things have changed. A lot of things are getting better. One of those things is observability, right? There's a much greater emphasis now on observability and how we look at the data and how we slice the data that we have coming out of our systems. And I think Honeycomb is doing an awesome job of this. A couple talks ago, we heard from Colton, who is one of the co-authors of lineage-driven fault injection, right? So this is like the whole idea of chaos engineering, right? This has gotten a lot smarter, a lot better over the last few years as well. Moreover, like the idea of like actually using formal methods of doing verification of large-scale distributed systems is something that is like gone from being almost entirely academic to now actually making inroads into industry as well. And then finally, like we also have things like what Chris McMullen talked about yesterday, where if we are building like better languages, better frameworks, better metaphors in many ways for talking about and writing systems, writing these large-scale systems, that like gets rid of an entire series of problems that we have. In fact, like to some extent, like if you look at VCL that Fastly uses, right? Did you realize that like when you write your VCL code, for those of you who use Fastly, that code that you write may actually run on multiple different machines for a single request, right? So it's an example of like the kind of thing where if you design a language in a certain way, it can actually be made to be transparently distributable. But wait, I thought this talk was supposed to be about edge compute. We're just talking about generic distributed system stuff. Yeah, that's kind of the point. When we talk about edge compute, what we're really talking about is this. We're talking about large-scale, coordination-free distributed systems. But beyond this, even beyond this, I think like the term edge compute is also a misnomer. All right. So there's this guy, John Gage. He was formerly the chief scientist at Sun Microsystems. You know, may they rest in peace. He was also, fun fact, a former member of Richard Nixon's enemies list in like the 1970s. Totally irrelevant to the story, but anyway. But what he was saying, he had this like really amazing quote that actually became a thing that Sun Microsystems talked about for a long time, which was the network is the computer, right? What he was talking about there is the compounding effects of having networked computers and humans working simultaneously, right? But I think it also applies to this thing that we talk about with edge compute. So my question is like, where does your application live, right? Some of you might say, oh, okay, my application lives in AWS. Others might say, oh, I'm actually a mobile developer. My application lives on the phone. Or maybe you're like a video developer. My application lives in the browser, in the video player, right? The thing is, though, that like your application doesn't live in a single place, and it's not a single thing, right? Your application is actually more like a tree. If you look at the root as the origin, all the way out to like the devices as the leaves of this tree. So even if you're like not actually intending to build a distributed system, that is in fact what you are typically doing, right? I mean, why? Why is that the case, right? So we certainly, like in most applications at this point, we have certain logic that runs at the origin. We have certain logic that runs at the device. Why do we do that? Because certain things are more efficient or only possible at certain parts of this like network tree, right? Like we could, in fact, render every frame of an iOS app on the server and just like, you know, display it there, but that's totally silly. Why would you do that? It's much more efficient to just do the display in iOS. Likewise, you could store all of every user's data on every user's phone. However, that's really clearly not what you actually want to do, right? So there are certain places in this network where certain things are more efficient and more reasonable. But when we talk about this, we always talk about it as like, oh, you know, we do things at the device, we do things at the origin, but there's more steps in there, right? Oh, there we go. Right, so if you're using Fastly, if you're using some other, like maybe you're using Amazon like Lambda or something like that, right? There are more steps between your origin and your device than just that one network hop. So it could go even further than that, right? It could actually be all sorts of things in between there. What we refer to as edge compute, in my opinion, the way I look at it, is actually more about pushing logic that was traditionally done at this origin out to the branches and the leaves of this tree. But it actually, in my opinion, goes far beyond like logic. What we're actually talking about in these cases is autonomy, which, again, Chris McMullen talked about in a certain way in his talk yesterday, talking about the idea of different pieces of this network being able to function without access to the other pieces. So the other part of like edge compute that I feel like is missing that isn't really discussed all that much at the moment, but I feel like is actually like a big missing piece, is that no one really thinks about the fact that the economics of computation change depending on where in that network you are, where in that tree you are. Computation actually becomes more expensive the further out from that origin you get. Like getting computation power in Ashburn, Virginia, or in San Jose, right? Very easy, very cheap. Getting it in like the data center that is like in that local region in Bangladesh, much harder, right? Much more expensive, right? And so like I feel like the other part of this that's missing, in addition to the new languages, the new frameworks, everything here, is like an actual platform for building these like edge compute applications. So that's the other part that we are hopefully working on right now at Fastly. And at some point, I will hopefully be back to tell you more about that. But thank you.